Analyze the components in the initial solution. The starting solution contains hydrochloric acid, HCl, and chlorous acid, HClO2. Hydrochloric acid is a strong acid that dissociates completely into H to the power plus and Cl to the power negative ions. Chlorous acid is a weak acid that only partially ionizes and exists in equilibrium with its conjugate base. ClO2 to the power negative HClO2 is in equilibrium with H to the power plus ClO2 to the power negative. Understand the reaction of adding a strong base. KOH potassium hydroxide is a strong base that dissociates completely in water to release highly reactive hydroxide, OH to the power negative, ions. Analyze the chemical shift on the weak acid equilibrium. As OH to the power negative ions are added, they react with and consume the free H to the power plus ions in solution to form water. H to the power plus OH to the power negative gives H2O according to Le Chatelier's principle. The removal of H to the power plus causes the weak acid dissociation equilibrium to shift to the right to replenish the lost hydrogen ions. HClO2 gives H to the power plus ClO2 to the power negative represent the overall net neutralization reaction. We can combine these processes to show how the weak acid molecules react directly with the added base. HClO2 plus OH to the power negative gives ClO2 to the power negative plus H2O. This reaction demonstrates that as the base is added, reactant molecules of the weak acid, HClO2, are consumed, while product ions of the conjugate base, ClO2 to the power negative, are generated. Relate to the final pH state. The pH of the solution increases from an acidic 2.4 to a highly basic 10.5. In such a basic environment, pH equals 10.5, the system lies far past the equivalence point of the weak acid titration. The chlorous acid will have lost its protons and will exist almost exclusively as dissolved ClO2 to the power negative. Thus, the absolute amount of ClO2 to the power negative increases, making option C the correct answer. The correct answer is option C, ClO2-.